I haven't uploaded anything in a couple weeks, so I figured I should make a short video that's pretty easy to edit just to keep the gods of the algorithm happy. And eventually, once I'm less busy with marketing and PhD applications, I will get back to making set theory and modular form videos and a whole bunch of other stuff. Oh, and finish the Gluing Lemma series. So I just thought, well, what's a quick, easy video I could make? Currently, I have 168 subscribers, which happens to be one of my favorite numbers, so I'll just make a quick video about all the reasons why I love 168. Now, I realize some of the things I'm going to mention are just coincidences. Some of them are coincidences with my actual personal life. I'm not suggesting there's any sort of numerological explanation for this, and the mathematical coincidences, some of them that I'm going to point out are just that. They're coincidences. It's not necessarily facts of significance. Nonetheless, partly why I love this number is because, these kooky coincidences do pop up. So let's go to the Platonic realm! So what is so great about 168? Well, let's start with some simple, trivial sort of stuff. Well, one thing is its prime factorization is 2 to the power of 3 multiplied by 3 multiplied by 7. And, well, I really like these numbers just so... this is of no significance to the number 168, but there's an open problem in graph theory that I'm obsessed with, which asks, it's the Moore graph problem, so you want to find all k-regular graphs on k squared plus 1 vertices, and you want the diameter to be 2 and the girth to be 5. So if you don't know what these terms mean, maybe I'll make a video about it one day, but for now you can just look it up. And it turns out that the only possibilities are 2, 3, 7, and 57. No other possibilities for k works. However, we don't know if 57 actually works yet. To this day, but the known ones are 2, 3, 7. So I really like these numbers wherever they pop up. And 57 is one of my other favorite numbers, so I'll make a video about that another time. There's lots of cool things to say about that. Another reason I like 168 is because it factors as 6 times 28, and these are the first two perfect numbers. I happen to be 28 at the time of recording this, so nice little coincidence. I love perfect numbers. Those are pretty cool. Another thing is that the number of primes, which are less than 1,000, this happens to be equal to 168 as well. We have the fact that 168 is the sum of 4 consecutive prime numbers. 37 plus 41 plus 43 plus 47 is 168. And also 42, which everyone knows is the answer to the meaning of life and the questions of the universe. It divides 168. So these are all fantastic little things about the number 168 that I absolutely love. Some other neat places where it comes up is that it turns out that that 168 is the maximum number of automorphisms of a genus 3 Riemann surface. So in particular, there's a Riemann surface that realizes this number, and it is known as Klein's chordic curve. So as a complex equation, it can be expressed as x cubed y plus y cubed z plus z cubed x equal to 0, and you look at the complex solutions of this. And this actually is the same thing as if one were to take the complex upper half plane and mod out by the modular curve gamma 7. So eventually my series on modular curves and modular forms. We'll probably talk about these sorts of modular curves at some point. So that's really cool. I mean, this is a really nice algebraic equation, and modular curves are really cool and fascinating in and of themselves. Now, it turns out, well, 168, so what precisely is the automorphism group here? The automorphism group is the group isomorphic to PSL27. So that is you take the special linear group of 2x2 integer matrices over the field with 7 elements, and you mod out by plus or minus the identity, and you get this projective special linear group. Now, this also happens to be the automorphism group of the Fano plane, which is the smallest finite projective geometry, and
which I happen to have tattooed on my ankle.
It also happens to be the address that I currently live at. It turns out that this isn't really just a coincidence that the Fano plane also has this symmetry group. I'll link some pages below, including something with John Baez, where he describes how one can find many, many different copies of the Fano plane sitting in, well, there's a realization of this curve as basically a tiling of the hyperbolic plane by septagons, so they should have 7 sides. So basically, you get this as septagon tiling, whatever, I haven't drawn it properly. And you look at certain vertices in this tiling and giving them some structure, it corresponds to the Fano plane. Fun fact, the Fano plane is actually connected to this Moore graph. There's a way to build the Fano plane, or rather, there's a way to build this Moore graph of degree 7 out of a whole bunch of copies of the Fano plane. Another fun IRL fact is that 168 is also my height in centimeters, BT dubs. Also, if we toss in both to the Fano plane and Klein's quartic curve, if we allow reflection symmetries, we get the total order is actually 336. And the cost of my coffee today I got at the fancy coffee shop down the street is $3.36. So, love it. Okay, so that's basically it. That's just a brief rundown of why I love this number so much. So if you want to see me go into more detail about any sort of this stuff, I could go into detail about prime numbers. I could make a video about these Moore graphs at some point. I do have a series talking about finite projective planes where I talk about the Fano plane in particular. I need to investigate this more myself, but I would even love to talk about other reasons why I think Klein's quartic curve is such a cool object, and say this corresponding modular curve. So please let me know down below which of these objects you want to hear more about and why they are so fascinating in and of themselves, and maybe let me know your favorite number and why.